The limit of a function is the value L that y approaches as x approaches a certain value a. Mathematically, we can write it in this form, and we read this as the limit of f of x as x approaches a is equal to L. So from this statement right here, when x approaches a, f of x also approaches a certain value, and that value is L, which is the limit of the function. So there are several laws and limits that we use to evaluate the limits of functions. So the limit of c as x approaches a is just the constant itself. So c is a constant. The limit of x as x approaches a is equal to a, which is the value that x approaches. The limit of c f of x as x approaches a is equal to c limit of f of x as x approaches a, meaning this constant right here can just be placed before limit. The limit of f of x plus g of x as x approaches a is simply equal to the summation of the limits of each function. The limit of f of x over g of x as x approaches a is equal to the quotient of the limit of f of x as x approaches a over the limit of g of x as x approaches a. Also, the limit of the product of f of x and g of x as x approaches a is equal to the product of the limits of each function. So the limit of f of x as x approaches a times the limit of g of x as x approaches a. And the limit of f of x raised to the power of n as x approaches a is simply equal to the limit of f of x as x approaches a raised to the power of n. So we evaluate the limit of the function first and then raise it to the power of n. So then let us use these laws to evaluate the limits of functions as well as compare it to when we use a shortcut in finding the limits of functions. So for example, number 1, we are to evaluate the limit of 3 of x as x approaches 2. So to use the laws and limits, because we have a constant right here, so we can just put it before the limit. So we write the 3 limit of x as x approaches 2. And so because this is just x, so meaning this is just equal to a itself. So 3 times 2, that is equal to 6. If we are to simply use a shortcut, then we are just going to simply substitute the value approached by x here to the x in the given function. So the limit of 3x as x approaches 2 is just equal to 3 times 2, which is equal to 6. So when x approaches 2, 3 of x, or the function, approaches 6. Another example, we evaluate the limit of x cubed as x approaches 3. So we have an exponent right here. So we can write this as the limit of x as x approaches 3 raised to the power of 3. And this right here is just equal to the value approached by x, that's 3. And then raise it to the power of 3, we have 27. If we are to use the shortcut, then we are simply going to substitute 3 directly here to x. So this is 3 raised to the power of 3, that is equal to 27. You still get the same answer. Another example, the limit of 2x minus 5 over x plus 2 as x approaches 2. So using the laws on limits, this is equal to the limit of 2x minus 5 as x approaches 2 divided by the limit of x plus 2 as x approaches 2. And because this is a sum, we evaluate individually the limits. That's the limit of 2x as x approaches 2 minus the limit of 5 as x approaches 2 divided by the limit of x as x approaches 2 plus the limit of 2 as x approaches 2. And then because we have a coefficient here, so that we can put that outside, so that is equal to 2 limit of x as x approaches 2 minus the limit of 5 as x approaches 2 divided by the limit of x as x approaches 2 plus the limit of 2 as x approaches 2. That would now be equal to 2, and this is equal to 2 as well, minus 5. Whatever value that x approaches, the limit of a constant is just the constant itself, divided by 2 plus 2. And so this is 4 minus 5 divided by 4. Our answer is negative 1 over 4. But then again, as I said, we can just use the shortcut. So the limit of 2x minus 5 over x plus 2 as x approaches 2 is equal to, we can just substitute this value here directly. That's equal to 2 times 2 minus 5 over 2 plus 2. So that's 4 minus 5 over 4. Our answer is still negative 1 over 4. Another example, we are to evaluate the limit of 2x squared minus 3x plus 4 as x approaches 1. This time let us just use the shortcut. So we're going to simply substitute 2 times 2 squared minus 3 times 2. Or rather, this is approaching 1. So that should be 1 squared. So 2 times 1 squared minus 3 times 1 plus 4. So that's 2 minus 3 plus 4. The answer is positive 3. This time, let's evaluate the limit of x square root of 3x plus 4 as x approaches 4. Again, let's use the shortcut. Substitute 4 to x. So that's 4 square root of 3 times 4 plus 4. So this is 4 square root of 3 times 4 is 12 plus 4, that is 16. And the square root of 16 is 4. So our answer is positive 16. So when x approaches 4, f of x approaches 16. Number 5, we evaluate the limit of 1 plus sine x over cosine x as x approaches 0. So by shortcut, we write 1 plus sine of 0 divided by cosine of 0. And we know that the sine of 0 is 0 and the cosine of 0 is 1. So our answer is positive 1. So here we have a fraction that leads us to a value that is specifically 1.